guys. Now we're going to continue our work on components of a vector. It's what Newton told us about way back when. This is an object that has been fired off at a 65 degree angle. 65 degree angle, and it's been fired at 230 meters a second at that angle. And what Newton said was that this vector has both a horizontal component, this dotted line here, and a vertical component. Sorry about that. And we make a little right triangle out of it. And so when we talk about this velocity, we like to call this velocity in the y direction, and this is velocity in the x direction. All right, and so we need our trigonometric functions to tell us how to break this into its components. And this is our hypotenuse, right? And since we're looking from this point of view over here, this is our opposite side, right? So we said that we use sine of theta is our opposite side over our hypotenuse, and then our cosine, which we won't use here, we'll use this next, of theta is our adjacent side over the hypotenuse. And what we don't use when we're breaking this up into components is tangent. But I want to write it. Actually, I'm not going to write it yet. Let's go back and let's use this sine idea. See the angle across from it. So our opposite side, our y component. So we're looking at the sine of 65 degrees is going to be equal to our y component of our velocity divided by 230 meters a second. Okay, and what we do is we want to get Vy all by itself, so we multiply both sides by 230 meters a second. Bloop, bloop. 230 meters a second. Okay, so this is 230 meters a second times sine 65 is going to be equal to our y component of our velocity. And so I'll take out my calculator. Just give me one brief moment to turn it on. Make sure I'm in degree mode. I am in degree mode. And I'm going to type into my calculator 230 sine 65. And I get about 208.5. So when I do this math, this is 208.5 meters a second is my upward velocity. And with this, what we're going to do later on is find out how long this object's going to be in the air, because we're going to have a formula that's going to help us. But right now, pardon me, we're just finding the components of these vectors. So here's the first component. That's my vertical component. Sorry about that. That was horrible. And now we're going to find our horizontal. Well, our horizontal, we said, was cosine. So we said the cosine of 65 is going to be equal to Vx. That's our adjacent side, Vx, over 230. And just like before, 230 meters a second. And just like before, we're going to multiply by 230 do that again. 230 meters a second. 230 meters a second. And what we'll end up with is 230 meters a second times cosine 65 is equal to our x component, because that goes away and that goes away, right? Is our x component of our velocity. So I'll type into the calculator again. Just give me a second to pick it up. 230 cosine 65, and it should be a little bit less, and it is quite a bit less. It is 97 2/10 meters a second. 97.2 meters a second. That's our x component of our velocity. I'm going to boost up the sound a little bit. There we go. So now we have x and y components of our vector. So I'm going to move on. I'm going to get rid of this. I'm going to move on to the next one. A gun is fired at 35 degrees above the horizontal at 350 meters a second. I'm going to create a line. I'm going to rough out what 35 degrees is. It should be just a little bit like that, right? And then I'm going to get rid of this. I'm going to label this. This is 350 meters a second. And what I'm going to do is I'm going to rough out the vertical component. And then I'll rough out the horizontal component of this velocity. And while it's not perfect, at least we have something that looks like a right triangle. This is Vy. That's velocity in the y direction, or the vertical direction, and this is Vx. And like before, here are the formulas. You don't have to go through these motions anymore. Vy, to find it, it is the magnitude, or the hypotenuse, magnitude, times sine of theta. And therefore this one is the hypotenuse times the cosine of theta. And they said that theta here was 35 degrees. So all we have to do is plug in what we know and we'll find our answer. So I'm going to do it real fast. I'm going to say that Vy is equal to 350 meters a second times the sine of 35. And then I'm going to go ahead and write out the other one. The horizontal is equal to 350 meters a second times the cosine of 35. And I'll type both of those in real fast while I grab my calculator. Give me a second. 350 sine 35 and 350 cosine 35. So 350 sine 35 is 200.8, just about. So Vy is just about 200.8 meters a second. And Vx is 286.7. change the color. Sorry about that. Vx is 286.7. Cool. And that's really it. Not really difficult stuff. You're going to do a couple of these, then you're going to move on, and we're going to find a missing side, and we're also going to find resultants of vectors. So let's go ahead and jump back over here, make this disappear, and it says sketch a diagram and add the vectors. Be sure that your resultant vector has a magnitude and a direction. So we're going to find an angle. And this is fun, right? We're going to say, I got to jump over here. We'll make a line, and I'll keep this color. We'll say straight north. This is 35. Oops. 35 meters. And then I'll make another line. I'll change that color. We'll do this, and we'll make it 65. And we'll make it way out here. And we'll call that 65 meters. And I apologize, I don't have a really cool way to measure these perfectly. But let me connect the dots with yellow. Oof, made a mistake. Humanity. There we go. And we're looking for the magnitude of this vector, which is using Pythagoras, right? Because we've got a right triangle. And we can look for theta. I'll either look for theta here or theta up here. I'll look for this one down here just because it'll be exciting. I'll use that one up there. Now, the first thing I do is use Pythagorean theorem. So the hypotenuse squared is equal to a squared plus b squared. And so I'm going to do that. So the hypotenuse is equal to the square root of 35 squared plus 65 squared. And of course I'm going to have to use my calculator because I do not know what those values are off the top of my head. So I'm going to hit the square root button, create some parentheses, 35 squared plus, plus 65 squared, close the parentheses, and the square root of that is 73.82. Or 73.8. So, does that make sense? Sure, it makes sense. It's larger than 65. So, the hypotenuse is 73.8. All right. Now I can use either the tangent function, because these are nice and round numbers, or I can use this hypotenuse. I'll get similar numbers. Right? So if I use the tangent function, it's opposite over adjacent, and we hadn't used the tangent, right? The tangent of theta is equal to opposite 65 divided by 35, right? And if I want to know what theta is, I just divide by tangent and divide by tangent. And when you do this, what you end up doing in the calculator is you're taking the inverse tangent, right? Remember when you had a denominator down here, some sort of variable, And you could put it up top and it would be to the -1 power. Well, that's basically what we're doing. And then we're going to put in 65 divided by 35. And I promise I'll show this one to you in class if we use the tangent. Either way, we would be using the inverse function. So I would say second tangent, and then 65 divided by 35, close the parentheses, and I get an angle of about 61.7 degrees. And that looks pretty close to what I'm looking at here. That looks pretty darn good. 61.7. And that's really all you do. 61.7 degrees. All right, so we have a hypotenuse of, or we have a distance of 73.8 meters, and at a degree measure of 61.7 degrees, and that is west of north. Wow, isn't that horrible? Awesome. There it is. That's the big idea. So we will go over this in class. The first part is really, really, really important. This is great. This is the second part of our work today, and I just wanted you to see it so we could get through it. All right, so take care. See you tomorrow.